Good morning, ladies and gentlemen. Today we're going to go over the Benchmark 10 Quiz A. In problems 1 through 3, we are asked to find the slope of each line. In problem 1, we have a point at 0, 3 and one point at 3, 1. If you remember from our lessons, the slope equals rise over run. So what we're going to need to figure out is how high we go divided by how far we have to go. So we can take the x values, subtract them to figure out how far we go up, because y measures how far up we go, and x measures how far across we go. So the y value of my first point is 3. The y value of my second point is 1. The x value of my first point is 0. And the x value of my second point is 3. 3 minus 1 is 2. 0 minus 3 is negative 3. So my slope equals negative 2/3. And that's all I have to do for that question. Question 2 is very similar. Some people like to subtract the y's and x's in a table format, so I'm going to do this problem in that way. The first point I'm choosing is 2, 3. So I put the 2 in the x column and the 3 in the y column. The second point I'm choosing is 0, negative 2. I put 0 in the x column and negative 2 in the y column. Just like in the first problem, slope equals rise over run, which equals y1 minus y2 divided by x1 minus x2. 3 minus negative 2 is the same as plus 2. Anytime we minus a negative, it's the same as adding a positive. So 3 minus negative 2 is the same as 3 plus 2. 3 minus negative 2 equals 5. And 2 minus 0 equals 2. Now we take the difference in the y's and put it over the difference in the x's, and we get slope equals 5 over 2. The third problem is the same as the first two problems in that we're just trying to find the slope. One nice thing about using the graph paper, though, is that we can simply count the steps. This is the third way of doing this type of problem. So we know that slope equals the rise over the run. Since we have our 2 points, we can just count the steps between them to figure out the rise and the run. In this case, it looks like the line is going downhill. So we know that a downhill slope is negative. So what is our rise? It's the difference in the y values, or the difference in the height. So in this case, we're going down 1, 2, 3, 4 steps. Down 4 steps. And we went across 1, 2 steps. So we rose -4 and we ran 2 steps. Of course, we can simplify this because 2 goes into 4, and our slope is -2. Questions 4, 5, and 6 ask us to find the slope of the line that passes through each pair of points. And once again, we are going to use the formula rise over run, or y1 minus y2 divided by x1 minus x2. I wrote the first 2 points in a table so that I can do my subtraction right there. 1 minus -1, when I minus a negative, it's the same as adding a positive, so that's a 2. And 3 minus 3 is 0. I put my y's on top of my x's, and I get 2 divided by 0. Can we divide anything by 0? We cannot. Therefore, it is undefined. Our second one has the opposite issue. When I put it in table form, I get 5 minus 5 is 0, 4 minus -4 is minus a negative, so I'm adding them. 4 plus 4 is 8. So I get 0 over 8. I can divide by 8, so that's not undefined, but if I divide 0 by anything, I just get 0. For my last one, I have -5, 2 and 5, -2. 2 minus -2 is the same as 2 plus 2, so on the top I get 4. -5 minus 5, I go 5 more to the left on the number line, so I get -10 on the bottom. I can simplify this because both of them can be divided by 2. So my slope is just -2 fifths. Questions 7 and 8 ask us to find the value of r so that the line that passes through each pair of points has the given slope. For question 7, the slope is 2/3. So we know that rise over run equals 2 divided by 3. How do we figure out the rise over run? Well, as you guys know, I like to put it in table form. So I have my first point, r, 2, my second point, 1, -2. I take 2 minus -2, it's going to give me 4. R minus 1, I can only write that down, I can't do much with it. But my rise over my run is my difference in y's divided by my difference in x's. My difference in y's is 4. My difference in x's is r minus 1. And I know that that equals 2/3. So now, all I have to do is cross multiply. Take that and I set it equal to that. So I take 2 times r minus 1, set that equal to 4 times 3. So 2r minus 2 equals 12. I add 2 to both sides, and I end up with 2r equals 14. If I divide both sides by 2, I end up with r equals 7. So I have found a value of r where if I plug it back into here, the slope between those 2 points will equal 2/3. For question 8, we do the same thing. This time we have a table with the first x and y value being -1, 2, and 2r. The slope, rise over run, equals the difference in y's over the difference in x's equals 3. Another way of writing that, of course, is 3 over 1. Our difference in y's is 2 minus r. Our difference in x's is -1 minus 2 equals -3. So we take our differences in y's and we put them over our differences in x's. 2 minus r over -3 equals 3 over 1. Once again, we take our cross multiplication and we set these two things equal to each other. -3 times 3 equals 2 minus r times 1. -9 equals 2 minus r. Now we have to subtract 2 from both sides to get -11 equals minus r. We can just get rid of those negative signs now and say r equals 11. Questions 9 and 10 asked us to write the equation in slope-intercept form. We know that slope-intercept form is y equals mx plus b, where m is the slope and b is the y-intercept. So all we have to do in this situation is plug in the slope and the intercept where you see m and b. So for question 9, we write y equals -2x plus 3. -2 is the slope, +3 is the y-intercept. For question 10, we write y equals 0x minus 3, where 0 is the slope and -3 is the y-intercept. Of course, we can write that without the 0x, just as y equals -3. Questions 11, 12, and 13 give us a graph and ask us to write an equation in slope-intercept form. We already figured out how to get the slope in questions 1, 2, and 3, and we know that the intercept is where the line crosses the y-axis. So let's get the slope for this line. Our first point is going to be 0, 1, the blue one that I already circled. Our second point can be over here, 2, 4. Now remember, there's two ways of getting the slope here. We can either subtract the y's and put them over the x's using rise over run. We get 1 minus 4 equals -3. 0 minus 2 is -2. So the rise is -3 The run is negative 2. And since we have a negative over a negative, that's 3 halves. The other way we did it was we took our first point and we counted up the steps going up. 1, 2, 3. That's our rise, and our run is how many steps we have to go over. 1, 2. So we have 3 over 2. And we know it's uphill means it's positive. So the slope-intercept form looks like y equals mx plus b. And we know that the slope is m, and the b is where it crosses the y-axis. So to plug in those numbers, we get y equals 3 over 2x plus 1. And that is our equation in slope-intercept form. We're going to do this one the same way. We're going to use the points 0, 1 and 2, negative 5. We know that the slope is going to be rise over run. We also know that this is downhill, so our rise is going to be negative. We go down 1, 2, 3, 4, 5, 6. Going down 6, we go across 2. Our slope is negative 3. Using the table form, we get the same. 1 minus negative 5 is the same as 1 plus 5, so we get 6, and 0 minus 2 is negative 2. 6 divided by negative 2 equals negative 3. So, putting it all together into y equals mx plus b, we have a slope of negative 3, and we cross the y-axis at positive 1. The last problem here, we should be able to look at and see it doesn't go uphill, it doesn't go downhill. We have a flat line going across. Therefore, our slope equals 0. And where does it cross the y-axis? It crosses at negative 2. Using our equation y equals mx plus b, we get y has a slope of 0x, and it crosses at minus 2. We can get rid of that 0x because 0 times anything is just 0. We get y equals negative 2, which makes sense because it doesn't matter what x is. Where x is 4, y is negative 2. Where x is negative 3, y is negative 2. Everywhere we go on this line, y equals negative 2. For question number 14 and 15, we're asked to graph an equation. Again, we're going to try using our equation y equals mx plus b. We know that the slope is going to be 2, and we're going to cross the y-axis at negative 3. So let's draw a line right there. We know it crosses here, negative 3. And we know the slope is 2. The rise over the run equals 2. So we must go up 2 every time we go over 1. So we go up 1, up 2, and over 1, and here's a point. up 1, up 2, and over 1, and here's a point. So we can draw a line right through these, make sure we put our arrows at the ends, and that's how we graph that equation. For number 15, we have y equals negative 1/2 x plus 2. Using our equation, y equals mx plus b, we know the slope is going to be negative 1/2, and the y-intercept is going to be plus 2. So let's put our first point there at plus 2 where it crosses the y, and then the rise over the run equals minus 1 over 2. So what this means is we have to go downhill. We're going to go down 1 to go over 2. Down 1 over 2. Down 1 over 2. Now we can draw a line. Make sure we put our arrows on the ends. And that is our graph.
Daddy.
Questions 16 and 17 ask us to write a linear equation in slope-intercept form to model each situation. Question 16 says a health club charges $25 per month plus a $50 joining fee. We see the word per there, which means this is the thing that we're going to be multiplying because it happens every month. So we know that the total cost is going to equal $25 times the number of months plus a one-time $50 joining fee. You can write this as y equals 25x plus 50, or in function notation, you just write it as f of x equals 25x plus 50. In this scenario, an airplane starts at 20,000 feet and is descending by 1,500 feet per minute. The starting height is the thing that's not going to change. He starts at 20,000 feet. The word descending is one of those words that means going down. It says descending, decreasing. So we know that his height starts at 20,000 feet and is decreasing at 1,500 feet per times the number of minutes. So we can write this as y equals 20,000 minus 1,500x. We can write it as y equals minus 1,500x plus 20,000. Those are the same things. Or we can write it as function notation. Any of these is a linear equation that models that sentence. The last 4 questions ask us if this is proportional or not proportional. The way we recognize whether a graph is proportional or not proportional, it has to be a straight line, and it has to go through the origin. This one is a straight line, but obviously does not go through the origin, so it is not proportional. The second one is a straight line, and it goes through the origin, so it is proportional. The last two questions, we can just look at whether the line itself goes through the origin by looking at the y-intercept. Remember that in our slope-intercept form, the y-intercept here tells us how far up or down, or in other words, how far away from the origin the line crosses the y-axis. So in this last problem where it says +1, that means this line is going to cross above the origin. So this is going to be not proportional. Over here, there is no y-intercept. That means that it doesn't go higher than the origin, and it doesn't go lower than the origin. It means it crosses right through the origin. So this is proportional. When you're looking at a linear equation and it's asking you if it's proportional, all you have to do is check whether it has something at the end. If it does, it's not proportional. If it doesn't, it is proportional. And that is the Benchmark 10 quiz.